Here's instruction for number 16, which teaches you how to balance chemical equations. Here's an example of what we're trying to do. We have words that describe an equation or reaction. They're here, and we're going to translate those into a chemical equation right here. There are 6 steps to success. The first suggestion is that you use a pencil. There are oftentimes you'll need to erase your mistakes. Step 1. Underline the name of each salt in the chemical equation. I'm going here to the words. Potassium sulfate is a salt. I'm underlining it. It has a first and a last name. The second name of salt is strontium chloride. The third is strontium sulfate. And the last is potassium chloride. So I've done number 1. There are 4 salts in the equation. Number 2, draw ionic pictures for each salt and write the proper formula under its name. So you see there's a space here. Under potassium sulfate, I can have a space for the picture and a space for the formula. Here's my picture. Potassium is a K with a plus. I get this from the periodic table. Sulfate, if you remember, serena sulfate is a more complicated ion. It's SO4 polyatomic with a -2 charge. This will require another potassium. You can see I've got 1 positive, 2 negatives. For every plus there's a minus. Means that this is potassium sulfate. So that's the ionic picture, and beneath it I can write the formula that describes that picture. 2 potassiums, 1 sulfate is written K2SO4. First one's done. Strontium chloride is next. Strontium is Sr with a +2 charge. Again, you find it on your periodic table. Chloride is Cl with a minus. And you can see I have 2 positives, 1 negative. Requires a second negative to make it a proper formula. SrCl2. The other side of the equation has 2 salts. Strontium sulfate. This should get easier because you've already found these on the periodic table. Strontium is the +2 ion. We've seen it before. There it is. It's still here. And serena sulfate. Make that a big circle. SO4 -2. That is strontium sulfate. SrSO4. If you ever find yourself inventing an atom that wasn't present in the beginning, you know you've done it wrong. So the strontium was already here. The sulfate was already here. That's the way it has to be. Last salt, potassium chloride, K+, Cl-. There it is. KCl. Okay, step 2 is now complete. Number 3 says let's add some more symbols. The symbol of plus and an arrow are almost always found in a chemical equation. So I'm going to write it here in this box. First I'm just bringing down K2SO4, not really thinking about it, just transferring it. And this is where I get to put a plus. The words reacts with means I have to mix them. So K2SO4 reacts with SrCl2. That's what the plus sign is used for. In the middle here it says to produce. So there's a chemical reaction, a change. That's this arrow. SrSO4 is produced. And KCl is produced. I've done number 3. And now I'm ready for 4, which says place underlines in front of the 4 chemical formulas to act as a placeholder for coefficients. So that's what this means. Line in front, line in front, line in front. I may need to put numbers in these spaces. That's what coefficients are. All right, so now we're in a situation where we get to do something new. We are going to look at number 5, which says balance the equation. Let's see if you can see the problem. Here we have 1 potassium, and you can see there's a second one. On the right side of the equation, on the product side, there's only 1 potassium. That's a problem. Needs to be solved. Sulfate's okay. You can see there's 1 sulfate here. I see 1 sulfate here, no problem. Let's look at the next set of atoms. Strontium is accounted for. It appears in the products, no problem. But chloride is a problem. I see 1, 2 chlorides. I see 1 chloride in the products. So here, I need 1, 2 potassiums in the product. So the way to do that is to add a second one. So this is where the second potassium must appear. Okay, plus. There must be more potassium chloride than we originally expected. Now, if we look at the other problem, here's a chloride, here's another chloride. There's only 1 chloride in the product, so we need to fix that as well. This is very convenient because if I add another chloride, then I have 2 copies of KCl, 2 copies of potassium chloride, and that is written this way, 2 copies of potassium chloride. This is called a coefficient. Here's the word coefficient spelled out for you. It balances the equation. I'm hoping you can see 1, 2 chlorides to go with the 1, 2 chlorides here in the beginning. 1, 2 potassiums to go with the 1, 2 potassiums that we had in the beginning. 1 sulfate, there it is. 1 strontium, there it is. Everything we had in the beginning appears in the end. That is what is meant by balancing the equation. All right, the last thing on the list is number 6. Add these phase notations to designate each salt, whether it is solid or aqueous. This is where you use your solubility chart. And things that are soluble will tend to dissolve. They'll be aqueous, that means dissolved, whereas insoluble salts must be solid, So if you look up each one of these salts, we'll know whether it's solid or aqueous. Potassium sulfate is soluble. Which means the phase designation should be AQ. Strontium chloride is soluble, which means the phase designation should be AQ. Strontium sulfate, insoluble, solid. And lastly, potassium chloride, soluble, AQ. So what you are trying to realize is that in the end, this line right here, this chemical equation that starts here with K2SO4AQ plus SrCl2AQ and ends up with SrSO4 solid and 2-KClAQ. That has a tremendous amount of information in it. That's called a balanced chemical equation. It is the chemist's tool for communicating what is this reaction, what happened.